Think about a standard basketball. Now, place a tiny, sharp grain of sand next to it. If that basketball represents the sun, that microscopic speck is our entire planet. You clicked because you want to grasp the true, terrifying scale of the star that powers your life. NASA data confirms the sun is 109 times wider than Earth, a distance so vast it makes our world look like a cosmic rounding error. While we call this place huge, the sun proves we are living on a pebble. Let's measure the abyss. To understand the sun's size, we have to start with the equatorial diameter. NASA's solar system exploration data shows the sun is approximately 864,000 miles, 1.39 million kilometers, wide. This is a number so large it loses all meaning without a reference point. If you were to take 109 Earths and line them up side by side like a string of pearls, that string would only just stretch across the sun's face. This 109:1 ratio is the first major mechanism of solar scale. It means the sun isn't just bigger, it is a different category of existence. If the sun were the height of a typical front door, Earth would be about the size of a nickel. When you look at the sky, the sun seems small, but that is a trick of distance. It sits 93 million miles away. If Earth were the size of a grape, the sun would be a giant exercise ball 500 feet away. The second best point to establish here is the volume. While 109 Earths fit across the diameter, the sun is a 3D sphere. Because of how volume works, you aren't just stacking Earths in a line, you are filling a container. NASA's calculations reveal that you could fit 1.3 million Earths inside a hollow sun. Imagine a giant glass jar. If you dropped one small marble inside to represent Earth, you would need over 1 million more to fill that jar to the brim. This cumulative math shows that our giant oceans and massive continents occupy a space that is practically invisible to the sun. We are a drop of water in a burning ocean. That realization would be enough to make anyone feel small. But what happened next made the volume look minor. We realized that the sun isn't just taking up space, it is holding the entire solar system together with its weight. As we move from size to mass, the tension moves from space occupied to gravitational power. Wait, before we calculate the sun's crushing weight, if you're finding this scale breakdown fascinating, hit subscribe. We're decoding the cold reality of the cosmos every week. The sun contains 99.8% of the total mass of the entire solar system. Everything else, Jupiter, Saturn, Earth, all the moons, and every asteroid, makes up a measly 0.2%. NASA statistics show the sun is about 333,000 times more massive than Earth. This leads to the gravitational anchor. Because the sun is so heavy, its gravity is the glue that keeps Earth from flying off into the dark. This leads to the solar wind and mass loss. Despite its size, the sun is actually bleeding. NASA's Parker Solar Probe has shown that the sun loses about 1.5 million tons of material every second to the solar wind. That sounds like a lot, but the sun is so incomprehensibly large that even after 4.5 billion years, it has only lost about 0.05% of its total mass. The real drama lies not in the weight it keeps, but in the heat it generates through its size. At the core, the sun's mass creates so much pressure that it fuses hydrogen into helium, reaching 27 million degrees Fahrenheit. Focus is your greatest weapon. That decision to stay at 93 million miles away is the only reason life exists. But what happened next made the sun's current size look small. We realized the sun is actually growing. This is the peak of the solar story, the red giant expansion. This is the highest informational value I can give you. The sun's 109:1 ratio isn't permanent. In about 5 billion years, NASA scientists predict the sun will run out of hydrogen in its core. When this happens, the sun will begin to puff up as it starts burning helium. It will enter the red giant phase. During this climax, the sun will expand until its outer layers reach the orbits of Mercury, Venus, and potentially Earth. At its peak, the sun will be over 100 times larger than it is today. If it is 109 times wider than Earth now, it will eventually be over 10,000 times wider. The Earth will either be swallowed entirely or scorched into a cinder by a star that fills half the sky. This is the ultimate grown version of our star. The reality of 2026 is that fusion and stability are the only things keeping the sun at its current size. There is a constant tug-of-war happening. Gravity wants to crush the sun inward, while the energy from fusion pushes outward. For now, they are perfectly balanced. The moment you see a sunrise, you are looking at a delicate explosion that has been perfectly contained for billions of years. But there is a silent trap waiting at the end of this success. Everything I just showed you about the sun's size is useless unless you understand the one thing I didn't mention at the start. Most people think the sun is the biggest thing in the universe. That decision to stop at our own star would have been enough to kill your perspective. But what happened next made the sun look like the grain of sand. We have traveled from the 109 Earth diameter to the 1.3 million Earth volume and the 333,000x mass. The resolution here is understanding that the sun is an average star. NASA's space-place data tells us that while the sun is a monster to us, it is a middleweight in the galaxy. You now have the roadmap to the sun's scale. You know why the 109:1 ratio matters, why the sun's weight holds us in place, and why it will eventually expand into a red giant. The expert status only comes after the very active work of realizing we are orbiting a medium-sized nuclear reactor. Bring your expectations down to earth. Focus on the fact that the sun is just the right size to keep us alive, so our species can actually take flight to other stars. But there is one thing I did not mention at the start of this video regarding hypergiants. Stars like UY Scuti or Betelgeuse make our sun look like a marble. If our sun were the size of a white blood cell, UY Scuti would be the size of the Empire State Building. Our 109 times bigger sun is actually a tiny speck in the grander Milky Way. Navigating the transition from amazed spectator to cosmic thinker is the hardest part of the journey. It requires you to stop being wowed by the big numbers and start being curious about the balance. If you can master this perspective, you won't just see a ball of fire. You'll see the engine of our existence. You have the data and the framework. Now you just need the discipline to keep looking up. The sun was not a giant that failed. It is a giant that stayed exactly the right size for us. The sun is a giant, but it's also a ticking clock. Watch this video next. It shows you the exact biological breakdown that happens to the human body during a 9-month trip to Mars. Click it now and I'll see you there.